Everyone. So in case of arrays, further we have what are the types of arrays. First is my one-dimensional array that we have already discussed in the previous sessions. Then we have the two-dimensional array and three-dimensional, or you can have n-dimension array. So let us discuss now the two-dimensional array. So two-dimensional array is a m cross n array represented as A, and it is a collection of m into n data elements, where m is basically your row value and n is representing your column value in case the array is stored in the row major order. We'll discuss row major order later in the session. So every element of the two-dimensional array is represented by two integer variables which are referred as the indexes or subscripts. In this case, suppose j and k, and the property is that j should be within the limits of this lower bound 1 or maybe 0 in case of C programming, and it should be also not beyond this m value which is representing the row. So this j can be your row or index to refer the row position, and this k can be the index position to refer the column position. So your two-dimensional array is a combination of rows and columns whose limit is going under this from this 1 up to this n or 0 up to the n in case we are using that particular language in which the indexing start from 0. So from 0 it will go up to n minus 1, and from this also it will go up to 0 to n minus 1. So this is representing my row and this is representing my column in case the indexing start from 0. Okay, so this is basically a two-dimensional array where every element is subscripted based on two elements. One is representing the row position and another is representing the column position. So it can also be denoted like this A, J, K, where A is the array name, J and K are the positions of respective row and the column number, or A, J, K. This can also be the representation. By default, in case we are talking about C language, the indexing of array start from 0. So in this case, this can be the representation for indexing 2D array elements starting from 0 index position. If we represent the 2D arrays further, the elements of 2D array A is shown as below. This can be the index positions of every element. This can be my 0, 0 element, means this is the value of j which is representing the row number, and this is the value of k which is representing the column number. So a element can be at a given row and column number, and it is referenced like this. This is the second element which is having the same row number and the column number changes to +1 from the previous value, that is k +1. Similar is the case with this. This is the third element and this is the fourth element, in which column number is changing and the row number keeps fixed. So it is moreover like a matrix wherever we have rows and columns as the things to refer that particular 2D array. Next we have first row. This can be referred as the 0th row as per the value of j becomes 0, and this is the value of j where the value of j is 1. So it is referring to the first row. See this thing, the row number is fixed and the column number is changing from 0 to 3. See, this row number is fixed, that is the first index position referring to the row, and then we have column number constantly changing by one position, 0 to 1, then 2 and then 3. Then this is the third row, or you can say second row or 2th row. This is 0th row. You can say this as the first row. This is first row. It will be your second one, and this will be third one. So based on this, we can have the rows figured out. This is same again, 2th row, and this is the column number which is keeps on changing from 0 to 3. If we further represent them row by row, so this is how the rows are being represented. Further, This is the way in which the columns of a 2D array can be represented. This is the column 0, this is the column 1, this is column 2, and this is column 3. So if we talk about columns, see this thing, the value of this row number, that is the first index, is changing and the column value is fixed. If we access the elements in this way, we can see that the row number is fixed, that is 0 in this case, and the column number is constantly changing, starting from 0 to going up to the value 3. So this is how the columns can be represented. If we look in this particular direction, vertical direction, so it will give me columns. If we give in the horizontal direction, so this is basically rows. And when we have talked about row major order, so we can say that elements are stored by row or accessed by row. Means this complete row of 4 elements will be stored in the memory first, after this second row, and then the third row will be stored. If we see that the array is stored in the column major order, in that case we can say that first the elements of first column will be stored, then second column will be stored inside the memory, then the elements third will be stored inside memory, and then the fourth column based elements will be stored inside memory. So this is how the difference is between the row major and column major representation, or you can say storage of elements inside the memory. Next is, it can be a two-dimensional array represented in memory by block of m cross n sequential memory location. So as the array says that it is a sequential memory location based data structure. Programming language will store the array either column by column, or it can store the elements row by row. So if it store the elements column by column, means first column, then second column, then third and fourth, so it is referred as the column major order representation of that array. If we store the elements by row major, so we have row major order. So this is the example for the languages which support this row major order. So as we are working in C programming in data structures, so this is the method in which we store the elements, row major order. Although if I want to store the elements by column major order, these languages are supporting them, Fortran in MATLAB. Even Java is supporting row major order. So by default, when we work with C, C++ and Java, the elements of the array are stored in the row major order. So if we talk about their representation in memory further, so this is how the elements are representing in memory. So if we take the subscript position as 0, means the first element as 0, 0. So this is the 0th column, this one up to this third element, and this is the first column, this is the second column, and this is the third column. Now we can say this is the third column because this 3 is fixed, second subscript is fixed, it is representing the column position. So if we talk about this kind of storage inside the memory as contiguous memory locations, so it is represented as the column major order. So in case of column major order, we have elements stored column by column inside the memory as contiguous memory blocks. In case of row major order, we store the elements row by row. So here we can see this is the first row containing 4 elements. This is the second row containing 4 elements, and this is the third row containing 4 elements. So this is 0th row because index position is 0. This is first row, index position is 1. This is second row, index position is 2, as 2 is fixed inside this particular first subscript position. So this is the case with the row major order of your 2D array represented in memory. Now in order to calculate the address of elements of 2D array, also we have a formula just like in case of 1D array. In this we use this formula, row major order as well as column major order based. This is the formula in which we can put the values and we can get the address of any particular element in case of 2D array, just like we did in case of 1D array. In this also, this is the name of the array where I and j are the index position of element which I want to calculate as the address, or whose address I want to calculate. Then this is the base address of the array, 2D array. This is the width again, the size of that element inside the array. This is m, n is basically that value of this row, how many rows are there in that inside that array, and this is how I represent the columns. Based on number of rows in column, we need to specify m and n in case of row measure and column measure order. So we multiply the value of row number by use of this j minus 1. J is representing the index position whose address I need to calculate, minus the lower bound value, and this is I minus lower bound will be added to it. In this case of row measure order, we have to use this column number to multiply with the row number, and based on this the address can be calculated. So let us try with an example. Suppose we have a 25 cross 4 array. That means 25 is the number of rows and 4 is the number of columns. The base address of the array is 200. Width per element is 4 bytes, and the array is stored in the row measure order with lower bound value as 1. So we have to compute the address of this particular element with the row number as 12 and column number as 3. Suppose the lower bound is 1, so in that case we have to calculate as per the value of lower bound as 1. So we put the value here as 1 in this formula, and based on this the formula is applied. 200 base address, 4 is the width. This is the value of, as it is row measure, so it is the value of n. M cross n array, so 25 is m and this 4 is your n. So based on this I can put this value of n here as 4, and 12 is your I value minus 1 lower bound. This is j value minus 1 lower bound. It will give me the address as 384. This is how we can calculate the address of a particular element inside the 2D array based on the row measure or column measure representation. This is the case with the row measure. In order to work out with the column measure, we have to apply the formula for the column measure order. Let us discuss this example now with the help of column measure order representation of addresses in the 2D array. This is a 20 cross 20 array, so m and n both are same, having values 20 and 20. Array name is A, base address is 400, the width is 4 bytes, and we are storing the array in the column measure order, unlike the normal row measure order, and the lower bound is again 1. We have to calculate the address of this element stored at position 10. So as per this formula, we have to calculate the value. This is the value of m, again 20. So if we put the values in this case, it will come out to 1156. So this is the case with the column measure order representation of memory addresses corresponding to an array.